So here we need to determine the derivative of the function x squared plus 1 over x squared whole cube. So what we're going to do here, we are going to apply the identity that a plus b whole cubed is simply equals to a cubed plus 3a squared b plus 3ab squared plus b cubed. So we'll have this will be equals to x squared whole cubed plus 3 times x squared whole squared over x squared plus 3 times x squared times 1 over x squared whole raised to the power of 2 plus 1 over x squared cubed. That will give us x raised to the power of 6. The 2 times 3 is 6 plus 3 times x raised to the power of 4 divided by x squared plus 3 times x squared multiplied to 1 over x squared whole squared will be x raised to the power of 4 plus x cubed whole cube will become x raised to the power of 6. So we have x raised to the power of 6 plus 3 times x raised to the power of 4 minus 2 plus 3x raised to the power of 2 minus 4 plus x raised to the power of negative 6. We have x raised to the power of 6 plus 3x squared plus 3x raised to the power of negative 2 plus x raised to the power of negative 6. So we find the derivative. So what we're going to do, we're going to find the derivative of a function. So we'll have d over dx of this particular function. So that is going to give us d over dx of x raised to the power of 6 is 6x raised to the power of 5 plus 3 times derivative of x squared will be twice of x plus 3 times derivative of x raised to the power of negative 2 will be negative 2 times x raised to the power of negative 3 plus negative 6 times x raised to the power of negative 6 minus 1, which is negative 7. So our final derivative will be 6x raised to the power of 5 plus 3 times twice x will be 6x minus 3 times 2, which will be 6x raised to the power of negative 3. So minus 6x raised to the power of negative 7. So this is going to be the final derivative. Let's move on to the next question. So we need to determine the derivative of the given function. So let us separate each of the derivative, or we are going to simply apply the derivative to each of the individual terms. So we have 3 times the derivative of tangent of x plus 5. So I'm pulling out all the constants from out of the differential derivative. So we have d over dx of log of x with base a plus d over dx of the square root of x, which can be rewritten as x raised to the power of half minus 3 times d over dx of e raised to the power of x plus d over dx of x raised to the power of negative 1, which will be equals to 3 times the derivative of the tangent function is secant square x plus 5. Now what we have to do, we have to first convert our log of x to the bases. So we need to change the base. So log of x can be written as the natural log of x divided by the natural log of a plus half times x raised to the power of half minus 1 minus 3, derivative of the exponential function is the function itself, plus negative 1 times x raised to the power of negative 1 minus 1. This will be 3 secant square x plus 5. Now log of a is a constant, so we can take it out of the differentiation or to the derivative. So we are left with the derivative of the natural log of x. So the derivative of the natural log of x is simply 1 over x plus half times x raised to the power of negative half minus 3 e raised to the power of x minus of x raised to the power of negative 2. So this is going to be the derivative of a given function. So let's move on to the next question. So we need to find the derivative of sine of x plus a. But before doing that, what we can do, we can expand. So this is a plus a, x plus a. So we can rewrite it as sine x times cosine of a plus cosine of x times sine of a. Now we're going to apply the derivative. So we have d dx of sine x plus a, and that will be simply equals to d over dx of sine of x times cosine of a plus d over dx of cosine of x times sine of a. Now a being a constant here, so we can pull it out of the differentiation. So we have cosine of a times d over dx of sine x plus sine of a was a constant, so we have sine of a multiplied to the derivative of cosine of x. So this is going to give us cosine of a times derivative of the sine function is the cosine function, so we have cosine of x plus sine of a times, so derivative of cosine function is the sine function, and we have negative sine of a. So that gives us cosine of x times cosine of a minus sine of x times sine of a. Now, this is sine of x here, I made a mistake. So here we have sine of x. Now, cosine of x times cosine of a minus sine of x times sine of a is simply cosine of x plus a. So this is going to be the derivative of our sine function, or sine of x plus a. Let us move on to the next question. So here we have the function sine of x plus a divided by cosine of x. So let us first expand sine of x plus a. So that will be sine of x times cosine of a plus cosine of x times sine of a whole divided by cosine of x. Now we're going to separate the numerator, so that will be sine of x. So let's write the cosine of a first. So we have sine of x divided by cosine of x plus cosine of x divided by cosine of x times sine of a. Now we know that the ratio sine over cos is simply the tangent function. So we have tangent of x plus the cosine x is going to get cancelled out, leaving us with sine of a. Now we are going to apply the derivative. So derivative of sine of x plus a, derivative with respect to x divided by sine of x is simply equals to, so derivative of cos of a times tangent of x, cos of a being a constant, we can pull it out of the derivative. So we have cosine of a times the derivative of tangent of x with respect to x plus the derivative of the constant function sine of a. A being a constant, the sine of a is also going to be a constant. Now we know that this derivative is going to be equals to 0. So we have cosine of a times the derivative of the tangent function, which is simply secant square a. So we have secant squared x. So this is going to be the derivative of a given function. Let us move on to the next question. So here we have the function, the x squared minus 3x plus 2 multiplied to x plus 2. So first, before finding out the derivative of this function, so what we're going to do, we're going to distribute each term of the first expression, x squared minus 3x plus 2, to each of the term of the second function, x plus 2. So we have x squared multiplied to x, so that will be x cubed plus x squared multiplied to 2 will be 2x squared. Then we have negative 3x multiplied to x, so that would give us negative 3x squared, and negative 3x times 2 will be negative 6x, plus 2 times x plus 2 will be twice x plus 4. Now let us combine the like terms, so we have x cubed, so positive 2x squared minus 3x squared is going to give us negative x squared. Then we have negative x plus 2x, negative 6x plus 2x, so that will be negative 4x plus 4. Now we're going to find the derivative of x squared minus 3x plus 2 times x plus 2. So it's the same as finding the derivative of the simplified form. So we have derivative of x cubed minus the derivative of x squared minus the derivative of 4x and the derivative of the constant function 4. So the derivative of x cubed is going to be 3x squared minus the derivative of x squared, which is going to be twice of x. Now 4 being a constant, we can pull it out of the derivative, and what we have is the derivative of x, that is simply going to be 1, and the derivative of the constant function 4 is going to be 0. So this is the final derivative value of our given function.